equation can be optimized by the different type of Bayes-Square optimization or meta-heuristic optimization. Like I can use the particle swarm optimization or the genetic algorithm GA, or we can use that algorithm. All kind of algorithm can use to optimize the weight. You optimize the weight of the equation. At the same time, if I further tuning the ANFIS, like the membership function of the fuzzy infiniteness system. In that case, I also added the PSO ANFIS. PSO ANFIS, or you can also use the GA ANFIS, that is the particle swarm, integrated particle swarm optimization of fuzzy ANFIS, or GA ANFIS, or flower pollination ANFIS, bat ANFIS. So this kind of optimization algorithm also be used for the further tuning of the fuzzy infiniteness system in a ANFIS model. So this kind of research I already performed this kind of optimization algorithm. But as my session is regarding the like a simulation related, so I just avoid this part. Actually, in optimization, some sources mean actually in MATLAB library you can get the code, but this code is not actually viable. You have to change the code according to your requirement. Okay, so I cannot say that is. You can have to, if you have some C programming languages, C++, you have to, and you have some experiment data, you can change the metrics of this algorithm, which are already available. But some of the algorithm you can also design, like implementing this two algorithm. That is the elephant swarm optimization. Okay, these are the actual hybrid algorithm. And some of the algorithm also be used like a hybrid of evolutionary algorithm, like genetic algorithm and particle swarm optimization can also be. Generally, what will happen in the most of the cases, some of the algorithm can provide the optimal result, because some of the algorithm gives the very fast convergence speed. Okay, that is after executing the instruction, it is very quickly reach to the stable condition. Okay, and some of the cases the algorithm takes the longer time. So I can choose these two algorithm and merge them. Then we get that hybrid algorithm. So this kind of algorithm we can also implement it according to the nature and your experimental data. So this can be have to implement this. So yeah, there is no particular sources for the optimization algorithm or MATLAB tool. Anyone else, please?
Any other questions to the participants?
Anyone have any question, please?
Okay, thank you, sir, for your wonderful session today. So here we would like to conclude the session. To everyone present over here, we would like to resume the session from 3:45 p.m. after a short tea break. Please stay with us.
Thank you, madam. Can I leave?
Thank you, sir. Yes, sir. Thank you all.
Recording stopped. Recording in progress. Recording stopped. Recording in progress. Recording stopped.
Hello. Mm. Hello. Dr. Nishant, am I audible? Hello. Dr. Nishant, am I audible? All the participants,
Recording in progress.
please stay with us.
Recording stopped.
Hello.
Hello, Dr. Nishant.
Yes.
Recording in progress.
Am I
Hello.
audible?
Am I
Yes,
audible?
sir.
Yes.
Yes, sir, you are audible.
Yes.
Sir, please share your screen.
Okay.
Yes, sir. It is visible.
Wait.
To all the participants, welcome for the next session. Before we start, I would like to introduce our next speaker, Dr. Nishan. So, thank you, sir, for your presence in our FDP. Dr. Nishant is a dedicated academician and researcher currently serving as a postdoctoral fellow at the Indian Institute of Technology. Dr. Nishant holds a Doctor of Philosophy PhD in manufacturing from the Department of Production and Industrial Engineering at Birla Institute of Technology, Mesra, Ranchi. He completed his Master of Technology in Mechanical Engineering from Jalpaiguri Government Engineering College and earned his Bachelor of Technology (BTech) in Mechanical Engineering from MIT Pune, Bihar. His academic and research interests focus on optimization techniques and modeling and simulation. Dr. Nishant has enriched his professional journey through impactful teaching and academic contributions. He has served as an assistant professor at Brainware University, Barashat, West Bengal, from July 2024 to September 2024, at BA College of Engineering and Technology, Jamshedpur, Jharkhand, from June 2024 to July 2024, and then before that, he was at DAV Institute of Engineering and Technology, Daltonganj, Jharkhand from January 2018 to June 2019. Each of his role reflects his commitment to fostering academic excellence and shaping the next generation of engineering professionals. Dr. Nishant is passionate about integrating advanced simulation tools like ANSYS into engineering education and research. His work emphasizes developing innovative solutions through optimization and modeling techniques, contributing to advancements in manufacturing and industrial engineering. So, today's topic is applying ANSYS in real engineering problems. Okay, thank you, sir. So now over to you. Please, you can start the session.
Thank you, ma'am.
Thank you.
Am I audible? Am I audible?
Yes, sir. You are
Okay.
audible.
First of all, I would like to thanks Techno Engineering College Banipur for inviting me for this keynote lecture on this 5-day faculty development program over the computational tool on engineering and research issues and challenges. And in this 5-day faculty program, I have seen there is a program in which a lot of keynote speakers speak about different types of computational tools and basically depending on AI. And I will try to express my view on applying ANSYS in real engineering problems in this keynote. And we will go for discussed in this session over the finite element analysis and computational fluid dynamics will be the two most important ANSYS topic in which we will focus mostly. Okay, let's start. Coming to the introduction part. What is ANSYS? It is a leading software suite for engineering simulation. engineering simulation, and it is widely used in industry and lot of research work. Some of the researchers hardly used ANSYS, and nowadays, not only ANSYS, there are more computational tools such as Console, Abacus, but ANSYS is one of the leading software compared to all other software, computational software such as Console. It enables the engineering model to simulate and analyze the behavior of structure. It gives the proper behavior of the structure, that how does the structure behave at the time of proper manufacturing, or the time of proper whatever the input or output parameter, input parameters you have applied onto the system. It also deals with the fluids and other physical systems. For fluids, the computational fluid dynamics is an important analysis in this ANSYS, which we will discuss in this session, and other physical system under various conditions before building physical prototypes. Suppose if we have developed a prototypes and we have fixed the boundary conditions depend on our need, depend on need of the industry, depend on the need of the research, and we simulate it with using this ANSYS tool with the help of either FEM, finite element analysis, or CFD. So why it is necessary to simulate such a prototypes before doing an experiment, or before going to in a field work or something like that? Because it helps industrial, it helps research, it helps researcher and industry. It saves times and cost, which both are the very important in product development and enhanced design optimization. It also enhances the optimization of the system. Well, ANSYS offer a broad range of capabilities that span different physical domains, allowing for integrated simulation and multidisciplinary design analysis. Some of the key features includes finite element analysis, computational fluid dynamics, electromagnetics, systems and multiphysics, optimization and design exploration, and the manufacturing simulation. There are many more, but these are the key features of the ANSYS design analysis. Okay. Though first of all, when we start, we go for the ANSYS. When we click on this, the basic thing is that what we need to know about ANSYS is ANSYS Workbench. Then what is the ANSYS Workbench? It is developed by ANSYS USA. It is a computer-aided finite analysis tool. In the graphical use interface of ANSYS Workbench, the user can generate a 3D and finite element analysis model and perform analysis and generate result of the analysis. So when we go to the workbench of the ANSYS, we see there is a list of analysis that can be performed in this tool. The first one is the design assessment. The assessment of the design can be done in this analysis in this ANSYS. And then there is then electric, there is expect dynamics, there is fluid flow, there is fluid flow CFX, there is fluid flow fluent. There is a minor difference between CFX and fluent or fluid flow. We will discuss in the coming section. Then harmonic response. Next is IC engine. If we go for the IC engine, the detailed analysis of IC engine we can used by using this analysis system of the ANSYS. We go for the linear bulking, magnetostatic, modal, random vibration, response spectrum, rigid dynamics, static structure. Static structure is also one of the important analysis in the ANSYS. Then steady state thermal, thermoelectric, transient structure, and transient thermal. Now, when we start the work ANSYS, how we should get this ANSYS onto your system? Before installing ANSYS to your system must have good configuration so that the simulation didn't get stuck when it's at the time of working. And it is recommended to have a system of RAM good RAM, more than if more than 4 to 5 GB RAMs is basically needed for ANSYS, and a good operating system also. The latest, if you have Windows 10, 11, you can use this ANSYS system onto your system very easily. And beside this, if your system provide a good graphic card, that will help to analyze the good picture and what the simulation result we have get, which can be visible in a very good manner. So the graphic cards is also one of the best, one of the most important for your system to install ANSYS in your computer or laptop, whatever you have. So when we go for the ANSYS workbench, when we go for the start, we see the workpiece. Now, from where we can download this ANSYS? This is very important. From where we can use the official website of the ANSYS, and we can use the student version of ANSYS. Latest version is also available there. You can go through it. As in this, I am using on 19.2 ANSYS. And student version is for students, and it is much equal to that, but there is some limitation to the student version. And if any institute or if anybody can go through the proper license of the ANSYS, that's good. Okay, so ANSYS for the workbench, we see a window will open like this, which will be named as unsafe product workbench. Now, this unsafe product you can rename by your whatever the system you want to rename it, that's all. And here see, there we have some the analysis system, which we have discussed in the previous slide. That these are some of the analysis system, and beside that there is a component system. This help this analysis system for the further analysis. For example, there is SCP post, pre, auto-driven CFX, engineering data, and there is so on. Whenever we click to the workbench, the window will look like this, and we will go for the next slide. So what this window represent? This window represent, the first is the title bar, where we can rename your data, where you can rename your file or save it with whatever you name you want. Then in this title bar, there is a menu bar, which we have file, view, tools, unit, extensions, jobs, help. In file, we can open it, save, as what we can do in the particular system. That's all the features is available in this. You can open it, you can save it, you can export it, you can import it, whatever you want. Similarly, there is the next, that is the project section view window, project section window. What is this? Whatever the analysis system we are going to use, we will just put it to this project schematic window. How will we put it? Just we go and click over the, for example, if I'm talking about the static structure, we go on the static structure, just click on it, or we will drag it to the project schematic window. That window will open up a pop-up of a static structure which have different which have different menu bars in that particular pop-up, which we will see in the next slide. Besides that, this is known as toolbox. It's a toolbox in which the analysis system, component system, custom system, design process, etc. are represented. Now, the one of the important thing of this window is that status bar. You see at the corner, left corner below, there is ready. In the status bar, there is written ready. That means that the system is ready for whatever the analysis system you are going to put into this the project schematic. This status bar will help you throughout your simulation, throughout your result, throughout your what you have to do. It will also give you a hint that what to do to next. What is the main error in your simulation? What is the main need? What you want now? It will give a little hint to you at every point of your analysis. Now, in a toolbox window, see in the right hand side we have the analysis system. The first is the design assessment. What is it is used? It is used to perform a combined solution for static and transient structure analysis. Suppose a particular researcher have to perform a combined solution for the static and the transient structure analysis, then he or she will do this design element. Similarly, for electric, they used to analyze the steady state electric conduction. For expect dynamics, it is used to identify the dynamic response of the conflict under stress wave propagation or time-dependent load or impact. Coming to the fluid flow CFX, it is used for analysis of compressible and incompressible fluid, used to analyze heat transfer in fluid. Next is the harmonic response. This is basically used to analyze the system working under periodic or sinusoidal loads. And the next is the IC engine. It will determine the performance of whole system of the IC engine. You can use the prototype of IC engine, whatever you analysis want to do. It will give the complete performance of the whole system of the IC engine. For using this, you can use in the fluent or FORT. That's depend what is the necessary of your analysis, what is the need of your research. That's all depend on your objective. Next is the linear bulking. It evaluates the bulking state of system under external load. Next is the magnetostatic. It analyzes the magnetic field developed due to the presence of a temporary or permanent magnet. Next modal, it is used to analyze the dynamic properties of models subjected to vibrations, random vibrations, random spectrums, rigid dynamics. These are used to determine the response of structure used after a transient analysis is done. And the rigid dynamics is determined response of a rigid body, or the mechanism consists of a rigid body. And the important is that this is one of the important for basically for the mechanical layer, that is static structure. It determines the response of the structure subjected to loading condition. The next, steady state thermal determines the temperature, thermal gradient, heat flow rates, heat flux under the influence of thermal loading. Then thermal electric simulates thermal and electric field. Thermal scale determines the response of a structure under the action of time dependent variable. Transient thermal determines the temperature and other thermal variation of a structure that's vary over time. So whatever the researcher or industry, what the analysis system you want, just you can simply click it and go for the further analysis. Now see, the next is the component system. Here we have, what is the use of this component system? These are used the basic block of the project. Whatever you have, whatever geometry you have made, this is used to the part to analyze systems such as geometry, which is used to create models for your analysis. Mesh we will go for. What is mesh? Used to generate FEM model. Then we used to visualize the result of ANSYS in desired form. Next is the custom system. Custom, it is used to carry out a standard coupled analysis in which input and output data of one analysis is used as input for the next analysis. And there is one more section in the toolbox, that is the design exploration. Here, it is used to explore a component so that the design of component can be further optimized by changing the design variable based on the performance of the product. This is the outlook of this ANSYS workbench. Suppose I have, for example, I have selected this static structure. When you click on this, or you will just drag it into the project schematic, you can see here a green rectangular box has been appeared in the project schematic. As you will leave your cursor, you will drag this static structure. A pop-up will develop at the project schematic, which consists of 7 parts, that is engine data, geometry, model, setup, solution, and the result. This is the overview. Here, for this, if anyone want to go for the fluid flow, if you want the harmonic acoustic or IC engine or model or rigid dynamics, just first step is to drag it to the project schematic and do the further analysis. Now, the important in the ANSYS work is the unit. The first thing we have to do that we have to decide the unit of this ANSYS workbench, on which unit we are going to be work. So in upper section you have seen in unit section there is SI unit, metric, metric ton, US engineering, and there's a lot of unit system is there. Based on your requirement, you can use this unit system. And there is, when we click on this unit system, you see there is more than, there are different types of unit system, SI, metric, US, and so on. The main thing here to see is that there is BCD. The B represent and there is a tick mark. It means this is the active project. See, there is the corner pause sign at the page. It is the default, and the cross sign in green is known as suppress. This is, first of all, when you open the ANSYS, your first when you open the workbench, your first priority is to check the unit. Because if you are going to not take a proper unit, your data will not give the proper result. Okay. Now, some of the component of that system, statistical system. First is engineering drawing. What is this? Engineering data. Then second is geometry, model, and mesh. Model and mesh. Model is something that meshing is under the model. There is a term known as meshing. Meshing means to mesh the particular your product into the small elements, small with the help of elements and nodes. Then setup, then solution, and finally the result. So engineering data cell is used to define material to be used in the analysis. The first things whatever the design you are going to analyze in this ANSYS, you have to define the engineering data. You have to define the material of that product, whatever the analysis you are going to do. For that, you have to use this engineering data. You can see when you click on this engineering data, a pop-up or a window will open in name of this ANSYS project workbench, and in left hand side there is toolbox in which the different properties are there, and at the middle of this there is the outline of the material. Suppose I have to click on the field variables and I have to read the value of temperature, frequency, or coordinate. Here is the list of material. You can use it, and if when you will click on this material, for example, the selection is of aluminum solid, then it will define it will show you all the properties of this aluminum solid. Here you show the density, it shows the molecular weight, it shows the formation enthalpy, it shows the reference temperature, it shows the formation, whatever. If your value is whatever the value is given into this system, this engineering data, if you are required, you can also use you can also see what the value is given to the particular aluminum solid here. If you are working on new material, you can also introduce your new material and you can define whatever the mechanical and chemical composition of the material is. Mechanical composition of the material is there. Coming to the geometry. What is geometry? It is used to create or edit or import the geometry used for the analysis. See, when we right click on the geometry, we see new place claim geometry and new design modular geometry. These are the two interface given to the ANSYS to create or edit your geometry, to create a geometry. You can use new space claim or you can use new design model. That's depend on you, whatever you like. You can. And if you have designed a part in SolidWorks or in any CATIA or any other softwares, you can also import that geometry. For that, we have to come to the geometry. Then you will see here is the import geometry. You can browse the location. You can give the file location. The geometry will be exported to this static structural geometry, and you can go for the further analysis. Now, see, these are the model cells. What are the model cells? After geometry, there is a model cell. It is used to discriminate geometry into small elements, that is meshing. It's meshed into small pieces, small elements. After, first of all, you selected the engineering data, then you developed geometry. After that, what we do, we discretize the geometry into small pieces. That is known as meshing with the help of elements and nodes. And we apply the boundary condition. and the load condition to solve the analysis. The next is the setup cell. It is used to define the boundary condition of the analysis, such system as load and constraint. If you are going to give a load, you are going to fix one side, or you are going to apply the whatever your boundary condition is, that depends on your analysis. You can define here in the setup cell. After that, you go for the solution cell. In the analysis the problem based on condition defined in the cell above the solution cell. Whatever the boundary condition you have given in the setup cells, based on that boundary condition, the solution will solve your whatever the analyze the problem based on the condition defined by you in the setup cell. And next is the result cell, which displays the result of the analysis in the upper specific format. Now, here is one thing we see that it in this pop-up there is some notation, that is click, question mark, filled question mark, tick, and so on. So what does it represent? This we should know. So and whenever you see that there is a engineering data and there is a green tick sign. A tick sign represents the required minimum data has been set. And when you go for the statistical analysis, the engineering data, this predefined is the structure stream. Okay. If now the notation is the filled question mark. What does it mean? It means the data is required before continuing. You are going to, you can see here, there is a green tick engineering data, but in geometry, there is a filled question mark. It means there is the absence of the geometry in the geometry section. When we go for when we build or design a part or anything into the geometry, then that will also green tick. It means that the minimum data what has been input has been given to the geometry section. Similarly, there is unfilled question mark. This section is unfilled. However, upstream data is required before this can be resolved. You can see in model, setup, solution, and the result, there is unfilled question mark. It means that whenever the data must be fed to the geometry section, then only the model and setup and solution and the result will work. Similarly, there is a refresh option, which section required review or modification. At any point, at any time, you came to know that, oh, I have missed something in that particular geometry or the particular model or the particular, I have to give one more boundary condition to the particular setup. You just edit it, and whenever you give the new data, you need to read refresh section. It shows that the refresh is necessary after each modification or what review required. The next is lightning bolt. Section required an update due to change in update data, and lightning bolt with pause solution was entered and need to be redone. And tick with arrow changes pending project symmetric may require further input. How we should create geometry in this ANSYS workbench? So when we'll drag this statical structure into the project view, we see and right click on this geometry, we see the new space claim geometry and new design modeler. As I've already told, this interface, the ANSYS provide you two interface for the geometry, and both will look like this as shown in this slide. And if you want to, you can also import the geometry here. You can also import the geometry here. You can also update your, suppose you have imported the geometry and you need the updation, you can also update it here into this particular section. Coming to this, I go for the design modular geometry for the geometry of this for this session. See, how does design modular geometry looks? It's look like this: statical structure design modeler. There is a file create concept tool unit. Again, I am saying unit is very necessary part. Whenever you go for this, you must check your unit. You must. This is the first thing you should apply to your analysis part. Then in the left hand side, you see there is the tree outline. It's tree outline. What does this tree outline show? This show the planes of this particular preview. How XY plane, ZY plane, and the YZ plane. These are the planes which we can use into this. Whatever, whenever you are going to design a geometry, design a part in the system, you will use to select that pin by clicking over there. Beside that, there is a menu bar, title bar. There is a ruler. Yes, ruler. Ruler is very important. This ruler give the what is the this scale to this particular image. Whatever the dimension you are going to use in the geometry, that is depend on this scale. There is two more tab, that is sketching tab and the modeling tab. When we first go for a sketch, then we go for the model. There is toolbar and so on. Now, from component system, you can also make the geometry. You can just slide this geometry to this project schematic, and you can also design your need of the geometry, new design modeler geometry. And you can also drag joining, you can use it. You can, there's no issue. You can use this geometry. You have not to, if you don't need to make your geometry second time. Just keep on this geometry and put that static structure and just connect it with that geometry. Now, okay, how we will create, or how we will be design or perform a geometry section. Suppose I am selected XY plane. Whenever you will click on the XY plane, this graphics will look like this. This is an isometric wheel. You can go through that to 2D also by looking at by clicking on the right click and look at, or you can see here at the upper part there is also a same logo. You can use there, or simply you can use this iso ball, this blue ball. That is the origin, XYZ origin of that XYZ. You can also use that ball, and you can just scroll with the help of your mouse, and you can adjust whatever the way you want to look to your geometry. Then after that, you have to go for the sketching. And sketching, click on the sketching. Whenever you go for the sketching, the line, polyline, polygram, rectangle, rectangle, 3-point, these are options will be available. And suppose you have selected the line. What happens when you draw this line to this particular XY plane? See, there is the origin and there is the end of that line. You can see there is two symbol. That is, one is at the origin is known as constant symbol, and at the end is known as the coincident point. And you see there is a written H. H represents the horizontal constant symbol. If you are going to drag the line in a vertical way, then there will be represented by a V, which is not a vertical constant. Now, suppose if you have drawn this particular model, drawn with the help of this design modeler and with the help of this sketching. Now see what you have done. You have just randomly, I have selected a geometry, and we have used some of the symmetry. You can see some of the constraint that each are equal distant, each are symmetry to each other, and we have developed this. This thing whatever, this is the basic, and this is the basic of any drawing structure. Any on SolidWorks or AutoCAD, you can use it. This is not a good job. Okay, next, what we do? What we go for the modeling? When we see there is the actual view, you click on the ISO ball view, is changed to isometric. Now, what we are going to do? We are going to extrude this. We are going to extrude this. How we are going to extrude this? You just draw this image and come to the click, and at the upper point there is extrude. When you will give the extrude option, it will represent like this. That waste the tree outline will show that sketch one has been extruded. When you will click on this type of image will be seen in the graphic section. And the detail of extrude we can give here. We can give the direction. We can make it, if we want to make it symmetry or unsymmetry, that can be given to the direct section. If we want to extend the type to be fixed, we can use it fixed. We can give up FD on depth, that is given in 30 mm. Whatever the details we want to give to this extrude section, we can edit it here in this particular section. Now coming to the next. Now, when you will exclude that geometry has become one part, you see in tree outline there is the one part and one body. If you are going to use two part, if you going to use two part in this geometry, then there will be two part, two body, and that's depends on your need of the sketch, how much the need of your model, how much body or part you want to do here. You can also use several another tools such as revolve. If you want to make a cylindrical or revolving section, you can use sweep, you can skin lock, you can thick, so you can blend, you can chamfer, you can trim. All these are already given here. You can use based on what you need in your geometry. Now, next is the meshing. Suppose I have, as I already told, you can just drag it from here. Suppose I have dragged max from here. Now I have made geometry in this section. What I have done, I have dragged this geometry to the another. No need to make the same geometry twice into this section at section B. Here we can go to directly to the meshing. It's meshing so that you can go for the refreshment. Now coming to the mesh, generate mesh, you will be give the detailed meshing. You can use the several meshing types, whatever you want, whatever the elements, you can increase or decrease the elements. You can use whatever you need, you can do on this meshing section. You can also update. If you are going to change this geometry once again, you can, when you will change it of geometry, you will have to update. You will have to, if you are going to change the elements, you have to change the editing the nodes, then you also update, and after update you have to generate the mesh, then you will go. Now coming to the first section, we will go for the finite element analysis. The finite element analysis, what is this? It is a numerical techniques for finding appropriate solution to boundary value problems for partial differential equation. As I already told in meshing that each part has been broken into small elements, that is meshed in small parts. In simple terms, it is a method for dividing up a very complicated problem into small elements, which can be solved in relation to each other. Useful for problem, it is very useful for the problem with complicated geometries, loading, material properties where analytic solution cannot be obtained. How FEA works? How finite element analysis works? Simplified step-by-step breakdown of how finite element analysis work is shown in the previous slide. First, we go for the pre-processing. Pre-processing, what we go for the defining the geometry, we go for the meshing, we go for the material property. Defining geometry, creating a representation of a physical object, component or structure to be analyzed. Whatever I want to analyze, whatever component I want to do, whatever component I want to, what I need for my research or for my analysis. Just you have to create a digital representation in the geometry section. After that, there is a meshing. The set divided into small steps. Each element is connected at the points, which is called as nodes. And the finer the base, the more accurate the solution, but it also required more computation resources. Material properties, assigning material properties, what is the elasticity, density, thermal conductivity to each element based on the material that the structure is made of. Then defining the boundary condition. It is one of the most important for FEA, finite element analysis. The boundary condition, defining constant and supports to your geometry. Where are the fixed point, where the rollers, where either they are symmetric or not symmetric, to determine how the structure is held or interact with its environment. The load, force, applied external force, pressure, temperature, or other load on the system where they interact with the materials. They could involve mechanical, thermal, or electromagnetic loads. That's all depend on whatever you need for the analysis. After pre-processing, there is the solution process. For solution process, you need the formulation, the system of equations. It uses the governing equation of the physics, such as law of motion or elements. This result is large system of equations that describe how each element will behave under the given load and boundary condition. The most of the error is due to this boundary condition, due to this not defining the proper boundary condition or not defining the proper constraint. Because if A little mist in this boundary condition will show an error to the simulation system. After that, if you are before when you go for the boundary condition, you should give the proper value, proper constraint, proper support, proper formulas, proper equation. You should have all these things for this boundary condition for your whatever the model you are going to whatever the for the analysis of the model or whatever you are going to use. Then solve the system of equation. The system of equation is solved using numerical method for such as Gaussian element or iterative solver. This is to determine the unknowns such as displacement, temperature, stress, and at each node. Then it is global solution. It is calculated for all nodes across the mesh, consider the interaction between the neighboring element to ensure consistency across the entire model. Then we go for the post-processing, that is interpretation. Result visualization. The solution is plotted and visualized using color maps or contour plots to make sense of how the material behave under load. Contour plots is just a representation, color representation of what the value is giving to the particular simulation figure. You can analyze or you can get from this contour plot. The next is the interpret result. And engineering analyze the result to understand the behavior of the structure, such as maximum stress, displacement, temperature. The key insight help to identify weak points, failure risk, or area of optimization. Validation and verification. Check the result for accuracy by comparing with experimental data and simpler analytic methods. Now see, what is this validation and verification? Whatever the data you have, whatever the result you have come from this simulation software, whatever the analysis you have done, now just to compare with your experimental data, is it valid or not? Is it validated or not? If it is giving that will not be accurate at the experimental, there will be a difference in the experimental and the numerical, but a very less 2 to 3 to 5% of difference is acceptable, and we can say that data. It means that whatever the simulation you have done using the whatever the boundary condition you have applied, whatever the formula, whatever the equation you have used in this in your particular system is fit to your is fit for this analysis, and you can validate and if you get this actual data, that is experimental data, and your predicted data is much more closer, then you can say my model is validated. If necessary, in some case, you need to optimize, you need to refinement of this data. Suppose you have done one analysis and you want to refine it, then you can mesh refine. You can do more meshing. You can break the meshing. You can make more and more small elements. Okay. If the results are not sufficiently accurate with you, suppose your experimental data and simulation data is having a huge gap, and you have done all things in a correct way, and since there is some huge gap, then you can use the refinement of the mesh. The model can be refined by using a finer mesh or by performing a local mesh refinement area where the solution changes rapidly. We can also, based on the analysis, engineer can optimize the design by changing parameters. If you want to change the geometry, if you want to material choice or boundary condition, you can optimize that design by changing the material, by changing the geometry or the boundary condition to improve performance. Then iterate finite mesh often to as an iterative process. Engineer might need to perform multiple analysis with different parameters to reach an optimal design solution. You don't need to go for the experiment for long term. You can do it on simulation based because you have already validated your model with the numerical experimental data. Now, what type of engineering analysis we can do using FEA? The first one is the structural analysis. It consists of the linear and non-linear model. Linear model use simple parameter and assume that material is not plastically deformed. The linear model consists of stressing the material past its elastic capacity, the stress in the material that vary with amount of deformation. This is one of the picture view of the statistical analysis used in the ANSYS. For vibration analysis, it is used to test a material against random vibration, shocks, and impact. Each of these incidents may act on natural vibrational of the material, which in turn may cause resonance and subsequent failure. Fatigue analysis. You can also do the fatigue analysis using FEA. It helps to predict the life of the material, the structure, and show the effect of cyclic load on the specimen. Such analysis can show the area where crack propagation must like to occur. Failure due to fatigue may also show the damage tolerance of the material. And you can also go for the heat transfer analysis. Heat transfer the conductivity or the thermal fluid dynamics of the material or the structure. It consists of steady state or transient transfer. Steady state transfer refers to constant thermal properties in the material that yields linear heat diffusion. Now, how will we do FEM in ANSYS? How will we apply this finite analysis, analysis in ANSYS? That is, similarly, we will go for the structure analysis. We will just drag it to this project schematic, and in project schematic we will go for the engineering data. In engineering data, what is engineering data? We will just define the material we are going to be used in this for this model. What model? For example, if here you have seen engineering data plus so the workbench. When you will click on this, that is the filler engineering data. There will be the list of material, and if we are in this section, you show that structure steel material is being selected. It is predefined material given to the ANSYS. Whenever you will not assign any material, that is the structure steel. You will always see a green tick in the engineering data in the ANSYS. It means that that is predefined, that is a structural steel. Now, you can change the material property if they are not the same. Suppose if you like the value of Young's modulus, it should be less or right. You can change it here, and you can give the details of the engineering material data, what you are using in this using for your analysis. You can just edit and put it here. After doing this, you just close this system and come to the point of the geometry. After this, just to close to the system to engineering data system and come to the geometry. Similarly, coming to the choose, we will select the choose the plane, XY plane, select the new sketch. If we go for the sketch for sketching, we go for this draw. For example, if you're going to use the, again here, first of all, we will go for the unit. Always remember to change the unit before starting sketching. And after selecting the unit, just suppose I have drawn a line. You can see here, just sketch the line, and I have make a rectangular section. And you can change the dimension by clicking here in the dimension section, or whatever you need to edit this. It is the dimension of this section. Now, next, what when if you are going to give to a circular section, if we are going to, I want to make this rectangular circular section. For that, what I do, we'll go for the concept and go for the cross section. And here you have a lot of cross section. For example, rectangle, circular tube, channel section, eye section, whatever section you want, you just click on this. That line will be changed into the circular section. For example, here the circular section has been selected. Now, when you go for this circular section, there will be a detailed view of the circular section. You can define the radius, and you can define the radius. Now, coming to the sketch, when you do this, there will be a part and the body will be represented in the that is your tree outline, in which if you go for the line body and you see the cross section is circular, you have also select here what is your cross section. Then you can your whatever the section of your geometry will be, that will be converted into the circular, and the radius you have defined in the air. Okay. Next. Now, after doing the geometry, you just close that window and just go for next, that is model, that is meshing, where you will go for the meshing. When you will click this model, you will see that is in outline there is a mesh. After the color, there is a option pop-up will be enabled. It's not a mesh. Just you right click on the system and generate mesh. When you will generate the mesh, the image will be shown like this, and the meshing will be appear. You can also define the detail of the mesh by clicking here. When you will click on the mesh, you will get the detail of the mesh. On statics, you can change the number of nodes, change the number of elements, and whatever that's need. You can edit the number of nodes and elements into the static section. Now, suppose I have what I have done. I have done this. Now I am going to do the analysis, and I have what I have done in this structure, static structure. I have made one thing fixed and apply load on the next section. In this circular rod, I have made one thing fixed and another to applying a load. Okay, how we will do that? Just we will go for the statical structure analysis in the setup form. And now what we will do? We will first click at the end point of the rectangular section which we have to fixed, and we will select the supports. Here you can see in supports, and we will use this fixed support. That's that point will be fixed. If you want to another remote displacement or frictionless support, or cylindrical support or simply support, you can change by using going to the support section, whatever you want. Now second, you go for load. You will go for load and pull out and put the force in the section point 2. In point B, we go for click on that point B, and we will go for the load and we'll apply the load. Whatever the load you want, you can give the detail of your load to the detail of the force. What detail you can use here. Just for example, I have given here 500 Newton in the downward direction, so I have used minus 500 ramp in the Y component. That is why this is positive Y. That's a negative Y. Here I have 500 Newton. Now, after doing this, there is an option of deformation here. Deformation. When you will select this solution, there is a deformation, and select this total deformation. Total deformation is throughout the geometry. Now go for the solving the FEM. The time to complete assembly depends on the problem size. Whatever the size of your geometry will be, the problem size and complex will take more time. After the completion, the numerical results are stored in the database. To solve the just to go to the solution and click on the solve. Whatever you will solve, the status bar will show each and every step what is going to be happened in the next section, and you will get this solution. From here you can see that we have got the maximum and the minimum deformation data based on this, based on the condition, based on the force we have applied to the rectangular that circular section. Now from here you can use the result, and you can whatever you want, you can do. Change the load, you can change the, you can whatever your requirement is there, you can just choose it and you can get the data. Now coming to the next is the computational fluid dynamics. It is a set of numerical method which is applied to obtain approximate solution of problem of fluid dynamics and heat transfer. It is not a science, but it is the way to apply the method of discipline to another fluid flow, material transfer, and heat transfer. Sometimes for the analysis of temperature and the material flow, for the fluid dynamics and the heat transfer, you need a user-defined function. What is user-defined function? User-defined function is just a code written by the particular user for what he's defined, in which he defined the particular set of what he wants in a particular way about regarding that fluid and the heat transfer. Why CFD? Why CFD? Why not we used FEM for the heat transfer, fluid dynamics? So it is not exact. That why not use analytical approach? Experimental approach is more reliable, such as wind tunnel experiment. Why not use experimental instead of CFD? It is because there are many engineering projects that cannot be solved by analytical or experimental approach. There are many engineering problems which can't be solved by by analytical or in experimental approach, or if it can be solved by experimental approach, it is too complex and too costly, or difficult to use the analytical or experimental approach. Thus, for those system, this analysis CFD of this ANSYS is very useful. What is this application? Where it is used CFD? It is a very powerful technique and span a wide range of industrial and non-industrial fields. Such examples are aerodynamic of aircraft and vehicle, drag and lift. As I already told, that what is going to be in the real life in the aerodynamics of aircraft, it is very complex to analyze at that point. So these are the application of CFD, where CFD can fluently used as a powerful technique. Next, power plant, combustion in industrial combustion chamber or gas turbine. These are the best, one of the best application of the CFD. Hydrodynamic of ships, biomedical engineering, blood flow through arteries and veins. This is also an important application of CFD where it is used. Engineering environmental and distribution of pollution. What are the methods of CFD? There is three basic methods, that is finite difference method, element method, and spectral method. Each method has their own specification, but the most common and the special case of finite difference method is finite volume method. It is very popular method. ANSYS Fluent. To solve this CFD, we go for the ANSYS Fluent. ANSYS Fluent CFD solver is based on finite volume method. Finite volume method. General coordinate equation of mass, momentum, energy, and solve the set and static control volume. For example, if you see this geometry, each basic section shows the controlled volume, and each volume is given by the general conversion equation of mass, momentum, energy formula you can use and you can analyze for that. What are the steps for the ANSYS Fluent? Similarly, for what we used in finite element analysis, the things are common, that is pre-analysis, geometry, meshing. But the physical setup, numerical solution, and the verification and validation. In setup, the boundary condition is different. In setup, the user-defined function is applied. Solution is different. That's which will used for the fluid and solid both in this CFD using ANSYS Fluent. How we will use this ANSYS Fluent? Just in the analysis system, you go for the fluid flow and just drag it to the system. We will use ANSYS here in the tool of simulation, Union Shift. You will use the control this tool from here. Here, all your tool needs from your simulation. You have access to all them with a single interface. Just to click in, drag it, or you double click. Suppose I have this is the one of the geometry of friction stir welding, in which we have I have performed this two material, different material. Both are of aluminum grade. We have defined the engine material. And tool is plunged at between the two plates. So how this this is the particular geometry of friction stir welding process. What we see, we have applied a boolean for this detail of boolean. What we have done, first we go for the first we solve we draw the geometry, we extrude the section, we extrude both the plate, we extrude the tools, and in each tools we give the we give the revolver. We selected the revolver condition into the tool, and we give the boolean. And boolean, we have in boolean operation we have subtracted. We have subtracted means that tool is going to be plunged and is subtracted from the workpiece. Now here, one is the body, that is the working workpiece, and second is the tool that is plunged. These two are the two bodies, as I've already told in previous slide, that there can be two or more than two bodies. In this section, I have used two bodies. One is the workpiece itself, one body, and second is this tool. And we had applied a boolean and operation subtract, so that this tool is subtracted from the workpiece. Now, see this we have two parts now. We have the workpiece. See, this is the workpiece. This is the workpiece, and second part, this is the tool. This is the workpiece. This is the tool. These are the two parts which I have defined in this geometry section. Now coming to mesh, we come to the mesh, go to the generate mesh, and we see the structure has been like this. When we go to generate the mesh in this section, we see there is the meshing. There is one in the outline tree. There is a mesh, and each nodes and each elements have been meshed a number of nodes, and the elements have been increased, and the meshing operation has been completed in the particular FSW process in this tool and the workpiece. Now, the next important is the name section. What is the name section? In name section, what we do, we name each and every edge of this plate, tool, and the workpiece. For example, if I have the red arrow, I have showed that it is the inlet of 6061 material. Similarly, on next side, we have gone to the inlet of 5083. Similarly, outlet, both outlet are same. That's the same. We have defined the sidewall by clicking on the sidewall from here or here. From top surface, bottom surface, workpiece solder in where the workpiece and the interface of solder we defined them, named it. Workpiece pin surface interface, to workpiece base interface, tool base interface, tool pin interface, tool solder. Each and every part has been renamed, so that in analysis, at the time of analysis, I get the clear view, and applying the boundary condition, we can get the clear incident. Oh, from here is the inlet, from here is the outlet, here is the sidewall, here is the top surface, here is the workpiece pin surface interface, each and everything. Now, see, similarly, how we will select the tool section? Just we will scroll our mouse with the using right click or using the scroller, and just select the tool pin and rename it as tool pin interface, tool base interface. Similarly, like this. Then we go for the meshing, and the meshing has been performed. And see, now we have applied a boundary condition into the setup for each and every tree. Whatever is the base material, what is the dimension, what is the material, what will be the tool rotation speed, what will be the welding speed, what will the feed given to the tool, each and everything, what are the formulation, general equation of energy, momentum, all of the equation, how does the tool interface interact with, what is the condition of that tool. Each and everything has been assigned in the boundary condition, and you can see here is a user defined. Before solving here, user defined. We have defined a user defined function using a code of C language for the analysis of material flow and temperature generation. We go for post processing, viewing, and then we go for the solution. As we go for the solution, as the simulation starts, each and every steps of the simulation is going to be written here, and in the status bar will show. If you have any error, the status bar will indicate you that what is the error, why your simulation is not running, what is the main reason. You just go and check it. Just check it and check it, then you can solve your process and you can do. And after this, you can go for and use the result. For example, I have used the result of the velocity streamline. It shows the complete velocity streamline of this FSW process. It gives you the minimum and the maximum streamline process. From here, we can generate the temperature data. We can generate the material flow velocity. We can generate what are the interaction, how the material flow. We can also play the animation. That's all depend on the what analysis we are going to use in for your particular section. Okay, this is the small talk over the FEA and CFD. I tried to cover up the important topic in this section. If you have any question, you may ask. Thank you. If you have any question, you may ask. Yes, the session is closed. You can ask question. Hello, am I audible?
Hello.
Hello, yes, ma'am.
Yes, ma'am.
Hello,
Sorry.
hello.
Sir, there is a question. What is the difference between ANSYS
Hello?
Workbench
Here.
and ANSYS APDL?
That's good. See, ANSYS Workbench is the basic. Whenever you are going to what the model you are going to use, what's your imagination about the model is, where you will give that particular section. That is the ANSYS Workbench. And APDL is the another thing. You can use APDL as a, for example, as I have used the Fluent, as I have used the CFD, as you have done the Workbench. You have to do the geometry, and then you have to drag this APDL to the that project section and just connect it, and you go for the analysis.
Hello. Thank you,
Yes,
sir.
okay, ma'am.
Any more questions from the participants? Sir, ANSYS is a tool.
ANSYS is a tool.
Sir, what kind of tool actually it is?
Ma'am, it's a computer for simulation for numerical, to solve a numerical model.
Okay.
There are different numerical model, and each in ANSYS there are different. This finite element analysis and CFD are only the few. There are many more. This is just the introduction section of ANSYS to know what is ANSYS, how we use it, how we can draw the geometry, how can we do meshing, just basic things.
The next question for CFD, how can we create user-defined programs?
You see, for user-defined function, you have to just nothing. You have to need a basic knowledge of C programming. You need a basic knowledge of C programming. Write on your notepad and use it as a C program, and just export it to the CFD function in the Fluent. In that program, what you have to do, you have to define your material, you have to define your temperature, what your needs based on your analysis, that we can define it here, which will have CFD function to analyze your data.
Thank you, sir, so much for your answer.
Thank
Any more questions? Thank you, sir, for your wonderful session. So here we would like to conclude the session today.
Thank you, ma'am.
And thank you all the participants. The attendance Google Sheet will be shared in the WhatsApp session. Please follow. Thank you. Thank you, sir.
Okay, ma'am. Thank you, ma'am.
Thank you all the participants for staying with us for this whole day. Hopefully you enjoyed the session and listen to all the speakers. So next day again we will continue with our FDP program. Thank you very much.